Okay, uh, now I start the today's topic, and the topic is sequential logic circuits. Before starting the class, all of you must sit with the pen and paper, pen with a pen and copy. Uh, so before starting the sequential logic circuit, I hope all of you remember the combinational logic circuit. In case of combinational logic circuit, your output is depends only on the present input stream. But in case of sequential logic circuit, your output is not only depend on the present input, but it is also depend on the past output. Okay, this is the difference. In case of sequential logic circuit, there is in some case separate memory element is also used, which can store the output and which is uh, used as per requirement at different times. So these are the difference between combinational and sequential logic circuit. So first we go through the definition of sequential logic circuit, and it is what? The logic circuit whose output at any instant of time of time depends not only on the present input but also depends on past outputs. Past outputs are called sequential circuits. So this is the definition. Here the your output is not only depend on the present input, but it is also depend on the past output. Now, next is next topic is next topic is flip flop. First, we discuss the flip flop and latches. Then I will start the latch first. So what is flip flop? Flip flop. So the flip flop, it is a 1-bit memory cell which store 1-bit logical data, that is 0 or 1. So by definition, the flip flop is a flip flop is a 1 bit memory cell it stores the 1 bit logical data. Logical data, that is logic 0 or logic 1. So flip-flop is what? It is the memory cell which can store 1 bit logic data. Either it will be 0 or it will be 1. Now this flip-flop is a number of type. So first is SR flip-flop, SR flip-flop. Second is JK flip-flop. Third is master slave JK flip-flop. And next is D flip-flop. And last one is D flip-flop. Okay. So these are the different types of flip-flop. Flip-flop. So we discussed the sequential circuit. So we already know the example of combinational circuits are adder, subtractor. These are the examples of combinational. And the example of sequential logic circuit is flip-flop and latches. So these all flip-flop, it is under the sequential logic circuit. SR flip-flop, JK flip-flop, master slave, JK flip-flop, then T flip-flop, and then D flip-flop. So this is flip-flop. After that, uh, in this all flip-flop I will discuss in details later on. But before that, we will discuss the latches. So next, first we discuss the latches. Latch. Latches. So latches is what? It is also a memory cell which is capable of storing 1 bit of information, that is logic 1 or 0. As discussed previously, flip-flop, same for the latches. So the sequence you can note down, it is a memory cell which is capable of storing 1 bit information that is logic 0 or 1. So as discussed uh, with the flip-flop, same, this latches is also the memory cell which is capable of storing 1 bit of information, that is logic 0 or 1. Then what is the difference in latches and flip-flop? In case of latches, there is no any clock pulses. So you can note down here clock pulse is not used. Clock pulse is not used. In case of flip-flop, clock pulses are there, but in case of latches, there is no any clock pulse. This is the difference in flip-flop and latches. Okay. So next topic, I will discuss the latches. So first, there is SR latch, SR latch, and it is also called set reset latch. Okay. Now this set reset latch, this, wait a second. First we discussed the block diagram of SR latch. So here, in case of SR latch, there are two inputs are there. These are the input side, R and S. Two inputs are there. This is input, input, and two outputs are there, Q and Q bar. Okay, this is the output. Two inputs are there, two outputs are there. So this Q and Q bar, this is the one is 0, other is 1. This type of outputs are there. Means it is the complement with each other. Q and Q bar is the complement with each other. If Q is 0, Q bar is 1, and if Q is 1, Q bar is 0. This type of output you will get. So this is the block diagram of SR flip flop. Block diagram. Next, this SR latch, this latch is designed by the NOR gate or by the NAND gate. Okay. So first, I will discuss SR latch based on NOR gate. NOR based SR latch. I think up to this clear. If anyone have any issue, then you can uh, send me the message. Or you can send me the comments. I will clear that topic, that point. Next, NOR based SR latch. So NOR based SR latch is what? It is designed with the help of NOR gate. So the circuit is like this. There are two NOR gates are used here. This is one NOR gate. All of you know NOR gate, it is the reverse of OR gate, complement of OR gate. This is NOR gate. R is means reset. this is Q, and this is Q bar. So here S and R is the input, this Q and Q bar is the output. So there are two NOR gates are used for designing the NOR based latches. Now next, all of you know the truth table of NOR gate. So in case of NOR gate, all of you know there are two inputs are there. Two inputs are there, A, B, and your output C is suppose A plus B complement. Okay, this is the input and output C equal to A plus B complement for the NOR gate. So here all of you know the truth table for NOR gate is what? Input, output. So input is A, B, output is C. When your input is 0, 0, here the output of the NOR gate is 0 plus 0 means 0, then 0 bar is 1. Okay, 0 plus 0, 0, and 0 bar is 1. So C equal to 1. If it is 0 and 1, then 0 plus 1, 1, and 1 bar is 0. Okay, same if it is your input is 1, 0, then 1 plus 0, 1 plus 0 is 1, then 1 bar is 0. And next is 1, 1. So 1 plus 1, 1, and 1 bar is 0. This is the truth table for the NOR. Okay. Now here in this case, truth table for the this NOR based SR latch is, you have to write down. So here the truth table for the this latch, truth table. So first there is the input, then output, and then there is a column action. Next, same, you know, here the input is what? S and R. S is the input and R is the output is what? Here you can see Q and Q bar is the output. So Q, suppose if at this time the Qn is the uh, output, then Qn plus 1 will be the next output. So here it will be denoted as, after applying the input you will get the next output, means Qn plus 1. So here your output will be Qn plus 1 and Qn plus 1 bar. This is same as this Q and Q bar. Okay, suppose at the time n you are applying the input and you will get the output at time n plus 1. Okay, so it is the Qn plus 1 means you are getting the output after applying the inputs. Okay, so next we discuss the, now you can see here, when here by using the S and R, 4 combinations will be there, 0, 1, 0, 1, sorry, 0, 0, first we take the 0, 0, 0, 0, then 0, 1, then 1, 0, and 1, 1. These are the inputs. Now you can see, uh, suppose first we consider this 0 1. Okay, first we start with the 0 1, then I will explain next this 0 0. First we start with this 0 1, means your input is 0, S is 0, R is 1. So S is 0, R is 1. In that case, you can see here, when any one input is 1, any one input means in case of A and B, any one input is 1, your output will be 0. Okay, any one input is 1, your output will be 0. Otherwise, your output is 1 when the both input is 0. So here, if one input is 1, then your output will be 0. So here R is 1, then whatever this input, here you are getting the 0. Clear? When this R is 1, so as per the truth table of NOR gate, your output will be 0. Okay? Because if the any two inputs is 1, your output will be 0. Any two input, any one output is 1. Any one output is 1, your output will be 0. So here, since R is 1, here it is 0. Okay. Now when this is 0, when this is 0, when this is 0, 0 means it is connected to this NOR gate. So this is 0 and this is also 0. So 0, here it is 0. So 0 0, it is 1. I hope it is clear. So when you supply the 0 1, in that case your Q will be 0 and Q bar will be 1. So here the Q will be 0 and Q bar will be 1. Okay, I hope it is clear. Okay. Next, when you apply the 1 0, so when you apply the 1 0, suppose when you apply the 1 0, means your S is 1, this is suppose cancel, your S is 1 and R is 0. When you apply the 1 0, in that case, where is eraser? Where is eraser? So next input we supply the 1 0. S is 1 and R is 0. So in that case, when the S is 1, R is 0, when S is 1, R is 0, in that case, you can see when any one input of NOR gate is 1, when any one input of NOR gate is 1, then your output is 0. So here this S is 1, means whatever this input, here the output is 0, means your Q bar will be 0, since S is 1. Now when this Q bar is 0, this is the input of this gate. This Q bar is one input of this gate. So here this is 0. So now this is 0. So R is 0, this is 0. So 0, 0, your output will be 1. Okay. So when you supply 1, 0, in that case, you will get the here 1, 0. Okay. I think it is clear to all of you. Next is, suppose we discuss the 0, 0. So when next when both the input is 0, 0 means S is 0, S is 0 and R is 0. Okay. So when S is 0, R is 0, in that case, now suppose here in this case, all of you know your Q is what? Q is equal to what? This is NOR gate. So R, this is R, and this input is Q bar. So Q equal to what? R plus Q bar whole bar. Okay. A plus B whole bar. A plus B whole bar. Same R plus Q bar whole bar. Okay. Now next, here when your Q is, suppose your Q is 0, if suppose plus Q bar, it is, wait a second. Achha, suppose you say this in this way. Just wait a second. Just wait a second. Leave this. Achha. Now suppose when the input is 0, 0, in that case, suppose previously the Q bar is, maybe you can assume anything, either 0 or 1. So suppose it is 0. So suppose previously the Q is 0 before applying the 0, 0. So if Q is 0, your Q bar will be 1. Okay. Now if Q is 0 means here this is 0. Okay. So 0, 0, your output will be 1. Okay. And here it is 1. So this is 1. So 0, 1, your output will be 0, 1, 0. Means if you supply, if your previous input is 0 and 1, then when you supply the 0, 0 to the input side, you will get the same 0 and 1. Okay. Means for the 0, 0, for the 0, 0, your output is same as previous output. Okay. So your output is same as previous output. So previous output is Qn and Qn bar. Okay. So whatever the previous output, it will be same as the as it is if you supply the 0 0 to the input side. Okay. Now next is 1 1. When you supply the 1 1 to the input side. To see what happens when we supply the 1 1, first erase this 0. So it is 1 when your S and R is 1 1. In that case, what happens you see here. Suppose same your previous output here, suppose it is Q is 0 and Q bar is 1. Suppose you can imagine opposite. You will get the same result. If previous input is 0, Q is 0 and Q bar is 1, what happen in that case? So since Q is 0, so this is 0, this is 0. So here 0 and 1 for this OR gate, NOR gate, one is 0 and other is 1. So 0 1 you can see wait for it 1 second. Wait for 1 second. Okay, sorry for the interruption. So when it is 1 1, in that case, suppose if the previous output is 0 and 1, Q is 0 and Q bar is 1, what happen in that case? So this is 0, means this will be 0. So here 1 and 0, you will get here what? One input is 1, so here the output will be 0. Okay. Now here in this case, you can see this is 0. Here now it is 0. So it is 0 here. Zero, and you can see 1 0, again it is 0. So you can see here this case, when you supply the 1 1 to the input side, 1 1 to the input side, in that case across the output you will get the Q is 0 and Q bar is 0. So it is not possible because Q and Q bar is complement to each other. So it is not possible. So this is the forbidden condition. When you supply the 1 1 to the both S and R, you will get the forbidden condition. Here it is invalid. So what happened? Here the action. When you supply the 0 0, you will get the same input as the previous one. Means here it is hold condition, or you can say it is no change. Hold or no change. Means your previous output is hold or there is no change across the output. 0 1, when you supply the 0 1, so your Q will be 0. So 0 means reset. Set means 1, reset means 0. So here your output is 0. When you supply the 0 1, your output is Q is 0. So it is the reset condition. And in case of 1 0, here the output is 1, Q is 1. So it is the set condition. 1 means set, 0 means reset. Okay. And when you supply the 1 1, In that case, your output is what? Invalid or forbidden condition. Forbidden. Okay, or invalid. So this is all about the NOR based SR latch. Okay. Same, this SR latch will be designed by using the NAND gate. So next topic I will discuss the NAND based SR latch. I hope it is clear to all of you. If you have any doubts, then you can uh, send the message. You can send the comment. I will wait for just one minute for your response. If you have any issue, then you can reply. Okay. Uh, Next, I will send you the. I will discuss the next point. This same SR latch will be designed by using the NAND gate. The next topic is NAND based S bar NAND based S bar R bar latch. So here circuit is same as previous one. Two NAND gates are used here. Two NAND gates. This is S bar. It is the S is for the state, and there is the R bar. R is reset. Same as the previous. Here one gate output is input to the other gate. So here output of this gate is input to, suppose this is gate 1 and this is gate 2. So gate 1 output is input of the one of the input of the gate 2. Same, your gate 2 output is input to the gate 1. Okay, here this is Q. Either you can write down Q, or you can write Qn plus 1, or it is Qn plus 1 bar. Means you are sending the suppose this is the time n, and you will you will provide that out time at input at time n, then you will get that output at time n plus 1, means next. Okay. This is, you can write q or q bar also, there is no issue. So now in case of NAND gate, all of you know the symbol. NAND gate symbol, two inputs are there, A, B, output C equal to what? A into B bar. This is the expression for NAND gate. We know the truth table for NAND gate. Input, output, truth table of NAND gate is, input is AB, output is C suppose. When 0, 0, so 0 in, first write the input, 0, 0, 0, 1, then 1, 0, and then 1, 1. Okay. 0, 0, 0 into 0, 0, then 0 bar means 1. Here it is 1. Okay. Same next, when the input is 0, 1, so 0, 1, 0 into 1, 0, and 0 bar is 1. Again it is 1. Then 1, 0, so 1 in 1 dot 0, so 1 into 0, 0, then 0 bar, again it is 1. 0 bar is 1. When 1, 1, so 1 into 1, 1, then 1 bar is 0. Here is 0. Now you can see in this truth table, when the one of the input is 0, then your output is 1. In case of A and B, any one input is 0, then your output is 1. Otherwise, it will be 0. Okay. Now, we discuss the truth table for NAND based SR latch. Okay. So, in case of NAND based SR latch, truth table. So, here same, here the inputs, then output, and then there is the action. Input and output is the truth table. Just we discuss the action what happened. That's why I add this column. Now input output. Your input is what? S bar and R bar. S bar and R bar. Output is Qn plus 1 and Qn plus 1 bar. Okay. Next, by using the S and R, how many combinations will be there? 4 combinations, either 0, 0, 0, 1, 1, 0, and 1. Clear? Now here you can see for 0, 0, same. First we discuss the 0, 1 and 1, 0 as before. Then at last we discuss the 0, 0 and 1. Or we can discuss the 0. We start with the 0, 0. Is it okay? First, suppose we start with the 0. So when the this both is 0, 0, suppose. So when both is the 0, 0, S bar is 0, R bar is 0. In that case, suppose the previous output is, you can consider either 0 or 1, no issue. If suppose it is 0 previously, then if it is 0, then it will be 1. Now if it is 1, 0, means this is 0. So 0, 0, your output will be what? एक जीरो होने से ही वन हो जा रहा है. You can see in the truth table, in case of NAND gate, if only one input is any one input is zero, then it will output will be one. तो दोनों में कोई एक zero हो जाए, your output will be one. You can see here, both are zero, your output is one. Okay. Now it is one, so this will be one. तो zero 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 one, इसमें यहाँ भी एक zero हो जा रहा है. So here the output is one. So now you can see here in this case, when it is 0 0, across the output side your Q is 1 and Q bar is also 1. Okay, and it is not possible, so it is the invalid or it is the forbidden condition. So when the S bar and R bar is 0 0, in that case you will get the invalid or forbidden condition. Okay, clear? Next we consider the 0. First I will erase it, then I will discuss the next one. So 0 1, 0 1, your S is 0 and R is 1. So here 0 1, so if S is 0, this is 0, for this gate you can see this is 0, so whatever the this input across the output we will get the 1, because any one input of the gate will be is 0, your output will be 1. So here you can see across the output side you are getting the 1, since here one of the input is 0. Okay, so here you are getting, now this is 1, so this is 1 is the input of this gate, both is 1 1, here you are getting 0. Okay. So for this 0 1 you are getting the set condition, your Q is 1. So for 0 1, for 0 1, this is 1 and this is 0. So your Q is 1, so it is the set condition. Okay. Next is 1 0. Same. First erase this. I will erase this. Okay. So next condition is 1 0. So 1 0, it means this is 1 and this is 0. Okay. So in this case, you can see here this input is 0. So for gate 2, one input is 0, you can see. So whatever the input of this second terminal, your output will be 1. Okay. From the truth table, you can see here, it is always 1. It is 1. Now this is 1, means this is 1. 1 1, when both is 1, your output of the NAND gate is 0. So here you are getting this. Okay. So your Q is 0 and Q bar is 1. So for this 1 0, your Q is 0 and Q bar is 1. Okay. So for 1 0, your Q is 0. 0 means reset. So you are getting the reset condition. Reset action. Okay. I hope it is clear to all of you. Next is 1 1. Okay. So next is 1 1. Means your S is 1 and R is 1. What happen in this? Suppose initially this Q is 0. You can consider 1, no issue. So suppose initially this Q is 0 and Q bar is 1. What happens? Now this is 0, means this is 0. So 0, 1. For this gate, one input is 0. So here the output is what? 1. Because any one input of the NAND gate is 0, you are getting 1 across the output. Now when this is 1, this is 1, so here 1, 1, output will be 0. Okay. Means previously the output is 0, 1, and after this 1, 1, you are getting the same 0, 1. Okay, means there is no any change, no change. Okay, this hold condition, or means here it will, you are getting the same output, so it is Qn and Qn bar. Whatever the previous output, you are getting the same output when you provide the input to 1, 1. Okay. It is the hold condition. Means there is no any change across the output when you provide the 1, 1 to the S and R. Hope it is clear to all of you. For the today class, I will stop at this. If anyone have any issue, then you can comments or you can send the message. Before that, I will send you the, wait a second, before that I will send you the attendance link. All of you go for the attendance. I will give you just 2 to 3 minutes for the attendance. All of you go to the attendance. Attendance link is given in chat box. All of you must give the attendance within 5 minutes, not more than that. Okay. Thank you. Today I will stop the class at this. In the class at and in the class at now, all of you go for the attendance and complete it within 5 minutes. After that, I will stop the attendance. Thank you everyone.